All right, Algebra 1 class, section 1-3, properties of numbers. So for this lesson is going to be a lot of filling out this chart and then just a little bit of examples, not a whole lot of examples. So just hang in there. I'll try to do it as quickly as I can on the video, and then you can pause and fast forward, whatever you need. Yeah, let's get into it then. Evaluate expressions. So the expressions 4k plus 8k and 12k are equivalent expressions. So what we're saying here is that 4k plus 8k equals 12k. So these are equivalent expressions. So the reason they're equivalent expressions is because they represent the same number. So 4k plus 8k equals 12k. And now, for most of the rest of this lesson, we're just going to be talking about ways that we can manipulate either side of an equation and the properties that we use to do that. So, properties of equality. So in this column, we're going to have a property. The second column is going to be symbols. And the third is examples. So the first property we're going to look at is the reflexive property. And this basically just says if I've got a number a, it equals itself. So an example with numbers would be 5 equals 5, or 4 plus 7 equals 4 plus 7. Any expression equals itself. Now, symmetric property. What we're saying here is if A equals B, then B equals A. So let's look at an example of what that might look like. So if A equals 2 plus 6, then 2 plus 6 equals 8. If 8 equals 2 plus 6, then 2 plus 6 equals 8. That is the symmetric property. How about transitive property? Now this says if A equals B and B equals C, then A equals C. So if A and B are equal and B or C are equal, that means that A and B are equal as well, because they both equal B and they're all equal. There we go. So let's do an example with numbers here. If 6 plus 9 equals 3 plus 12, and 3 plus 12 equals 15, then 6 plus 9 equals 15. So if these two are equal and these two are equal, then these two are equal. A, B, C, A. Okay, good. Next, substitution property. if A equals B, then A may be replaced by B in any expression. So let's see what we're talking about here. So if n equals 11, then 4 times n is the same as 4 times 11. So we've substituted 11, or replaced n with 11. We've substituted 11 for n, or replaced n with 11. So that's how that works. That's how substitution works. Now we've got this other chart down here to fill out, and then just a couple examples that we'll do on the back. We have a property, and then we are going to do the addition portion or application of that property, and the multiplication application of that property. Okay, so we've got 5 properties here: commutative, associative, identity, inverse, and distributive. Okay, let's look at the commutative property of addition. This says if I have A plus B, then, not plus, A plus B equals B plus A. It's just saying I can move these around. If I'm adding everything together, it doesn't matter what order they're in. Same with multiplication. A times B equals B times A. So that is commutative property. I can move those around a bit. I could also say, let's do one more here in this multiplication here. I can say A times B times C equals B times C times A. I'm just saying I can move these around. It doesn't matter. As long as we're all multiplying here, they can be in any order. Same with addition. Okay, let's look at the associative property. Now, this one, for addition, notice it's all of these numbers are being added together. So if I have A plus B in parentheses plus C, this is the same as A plus, and then I have my parentheses B plus C. This is similar to commutative, but it's a little bit different in application. But what I'm saying here is if we're adding all of these together, and they're all the same numbers, we're adding all of these together, they're the same numbers, it doesn't matter how I group them, they still equal one another. Same thing with multiplication. A times B times C equals A times B times C. I'm just saying if I'm multiplying everything and I'm multiplying everything, all the same numbers, I can group them however I want. It doesn't make a difference. I should still have the same answer on both sides. Identity of addition, A plus 0, any number A plus 0 equals that original number that I started with. Similarly with multiplication, A times 1 equals A. Any number times 1 equals that number. Inverse. A plus negative A, so any number added to the negative version of that number equals 0. That's a funny 0. Similarly, in multiplication, but a little bit different, right? Inverse, A multiplied by 1 over A equals 1. Should we look at that a little bit further here? What I'm saying here is a over 1, that's the same thing as a right here, times 1 over a. I multiply straight across, so that'll give me a over a, which equals any number divided by itself is 1. So that's the inverse property of multiplication. And now the distributive property here. This one is not addition or multiplication, it's just the distributive property. And it works like this: a times b plus c in parentheses here equals, what we do here is we say a times b and a times c. We distribute this, whatever we're multiplying by, to both of these numbers. So I get a times b plus a times c. So that plus comes from right there. Okay. And then we have filled out this chart. Now let's just do a couple of examples on the other side of this page. Okay, so the way these this homework is going to work, and the way this example works, is I'm going to give you an expression: 7 times 4 minus 3 minus 1 plus 5 times 1/5. And so we're going to start with this expression, and then whatever we do to this expression, we need to say what that property was from this other side that we used to make that change. So the first thing we're going to do these parentheses here. We're going to do 4 minus 3. Okay, so 7 times 4 minus 3, which is 1, minus 1, we're just going to write out the rest of the problem here, times 5 times 1/5. So what we did here is we did substitution. Substitution. 4 minus 3 equals 1. That was our substitution that we did. Next, we're going to do the 7 times 1 here. So 7 times 1 is 7. And then I'm going to say minus 1 plus 5 times 1/5. And so that would be 7 times 1. Remember back here on this page, any number times 1 equals that number. So we did the multiplicative property, the identity property of multiplication. And so the way we're going to say that is we're going to say multiplicative identity. And that was 7 times 1 equals 7. Okay. Next, we need to let's do this part. Okay, we'll leave the 7 minus 1 here, plus 5 times 1/5. So 5 times 1/5, or 1/5 of 5, is 1. And so that one is called the multiplicative inverse property. So that is 5 times 1/5 equals 1. All right, next one. Now, these last couple ones are both going to be substitution. So when in doubt, and it's just kind of, 7 minus 1 is 6, and then plus 1. So this is going to be substitution. Substitution. And that is 7 minus 1 equals 6. And then the last one, 6 plus 1 is 7. That one is also substitution. 6 plus 1 equals 7. Okay, now this is how I want you to lay out and do this U-try here, which is 2 times 3 plus 4 times 2 minus 8. All right, so you're going to do each step just one step at a time and list which property you used to make that change. So go ahead and pause, and then we'll come back and go over this together. Pause. All right, let's see how you did. Let's do the parentheses first. So I've got 2 times 3 plus. Now in the parentheses, I might be tempted to say 2 minus 8, but I need to do the multiplication first. Multiplication and then division comes before addition and subtraction. So 4 times 2 is 8, and so I've got 8 minus 8, and so I'm going to, so 4 times 2 is 8, I'm going to call that substitution, which is 4 times 2 equals 8. The next thing I'm going to do, so whenever it's just a common, multiplication thing, addition or subtraction, and it's just a normal deal, just call it substitution. Next, I'm going to do 8 minus 8. So 2 times 3, 8 minus 8 is 0. So 2 times 3 plus 0. 8 minus 8, now do we have a property for that one? Any number added to the negative version of that number is 0. So we've got the addition inverse. So the additive inverse property, which is 8 minus 8 equals 0. Next, let's do this 2 times 3 here. I'm going to leave this plus 0, even though usually we just ignore it. We're going to leave that here just so that we have something that we can say about it. So I've got 2 times 3 is 6 plus 0. So I'm going to call that substitution, which is 2 times 3 equals 6. And then the last one here is 6 plus 0 equals 6. So 6 plus 0 equals 6. We have the identity problem, right here, property of addition. So I'm going to call that additive identity. And that is 6 plus 0 equals 6. And that is all we have for Algebra 1, Section 1-3.